you guys can get started. Thanks.
Thanks, Diana. Let me add deck. Awesome. Hello, everyone. Thank you so much for joining today's session presented by UiPath's Denver chapter. Today, we are going to talk about the AI Center, how you could bring your own model, an overview, and then at the end, we'll be doing a Q&A session. So before we go, let me give you a quick introduction about the Denver chapter. So we here at the UiPath community in Denver are a virtual community. Our focus is to build a community with RPA and DU enthusiasts, developers, and anybody who is curious to know the latest technologies introduced by UiPath. So our organization team consists of Diana Gray. She's the head of UiPath communities in Americas. We've got Saideep Kandibanda, who's a Denver chapter lead. He's the RPA manager at Dish. We've got Rashmi. She's also a Denver chapter lead, and she's also a senior RPA developer at Dish. And we've got myself. I'm a machine learning consultant at Ashling Partners. And today's session, we have a key speaker here with us today. He is no stranger to the Denver chapter. He is UiPath's ambassador to Americas this year, and he's also MVP. Russell Alfeche, he's currently the technology leader for Cubotica. Russell, can I hand over the floor to you to give a quick introduction about yourself?
Sure. Thanks again, Sharon, for having me here. And yes, as Sharon said, I'll be leading this session, or at least for the demo. And also Sharon will be going to some overview. And excited for this demo, so to showcase what we prepared for you.
Great. Thanks, Russell. So let me go ahead, giving you an iteration of the meeting agenda again. So I'm going to talk about the AI Center refresher. And once we're done with that, Russell will go in to talk about how you can create your own machine learning model in AI Center and how you can deploy that. Throughout our session, feel free to add your questions in the chat. Once we are done with it, we will be taking all your questions and we'll provide answers to them. All right. Thank you, everyone, once again. So AI Center. So I'm assuming you have at some point, if you work in RPA, you've heard of it. You've worked with it. If you guys like, do add in the chat your skill level of AI Center. If you do not know or you haven't experienced AI Center, I could give you an in-depth conversation about how the AI Center works. But essentially, what is AI Center? So AI Center in UiPath is the space where you can create and package machine learning models that you can use in your automation. Now, AI Center is part of document understanding. So for example, if we are developing a document understanding model and we use a machine learning model to accommodate our DU model, we create and deploy that model in AI Center, right? So if you have any experience with it, you would know that you can create the ML skill, and that ML skill would act as an endpoint for your document understanding automation. Now, looking into this slide over here, you can, this is a UiPath presentation on how the AI Center ML model is created. So essentially at a high level, you can choose a model, and I will talk in depth about how you can choose and what kind of solutions are there in AI Center. Once you choose your own model, you can build an ML skill in UiPath's AI Center, and that ML skill gets deployed into UiPath Studio, where you can either use it in RPA, document understanding, automations. Looking into that over the left side, you can see that you have three nuances here. You can either choose a pre-built model, you can bring your own model, or you can pick a model from UiPath partners. So I will talk a little bit about them in our following slides, but to give you an idea, UiPath offers different pre-packaged models where you can simply integrate with your existing automation. Now, this will save you a lot of time on compiling and testing and building your own machine learning code, where UiPath here offers different solutions where you can just integrate, train, test, and deploy them as an ML scale. Great. So I was mentioning that UiPath offers different models. So what are those models? So if you see over here, you'd see UiPath document understanding, language and image analysis, and open source models. So if you go into AI Center, you'll see a ton of machine learning packages, as they'd call it, inside the AI Center scope. So UiPath offers their own document understanding models for a lot of these document types. So what does that mean? So if we take invoices, for example, and you want to use a document understanding model, this would mean that the invoice has been pre-built, which means that there will be a certain algorithm within this model where you can use to identify fields and values in your production data. So UiPath offers models for all these document types, which you can see and use in AI Center. They also offer different language and image analysis entities. Say you want text classification, image classification, identifying semantic similarity. You can use those models to build a machine learning model to deploy in RPA. And then we have open source models, which means models that were not developed by UiPath, but by third parties like Facebook, Google, etc. So you could use these open source models for different entities like text classification, text summarization, object detection, and all of these other variations that are mentioned here. So I want to show some screenshots on the AI Center that I took today. So UiPath develops a lot of machine learning packages, and the machine learning package stack keeps increasing day by day. So if you go into AI Center and if you go into ML package, this is what you're going to see. You can either upload your own zip file, which means you can upload your own ML package that you've compiled. You have out of the box packages, or you can import an ML package that was exported from AI Center previously. Say you had an ML package in a different environment and you want to import it into your current environment. So in that case, the import ML package would be the solution that you use. So let's go ahead with the out-of-the-box machine learning packages that are available. So when you go into out-of-the-box machine learning packages, these are the packages that you're going to see. So you have a very good variety where you have computer vision, you have document understanding, image analysis, language analysis, and task mining. So today I'm going to look deep into document understanding. Let's go ahead with that. So you can see there are quite a few of the ML packages available for document understanding. So almost all of these are retrainable, which means you can train it over time, and the machine learning model has an iterative capacity where it can train. So if you have, a certain number of data right now, and in production you see different sort of data, you can always keep training these ML packages. I believe the only ones that you cannot train are the document OCR and the document OCR CPU ones, but the rest are trainable. So some of the other ones here are, you can see that there are predefined documents for all document types. And I will share a link on the chat. This is a UiPath resource where you can find out what the pre-trained packages are and what their pre-trained identifying fields are. So with this, you might identify, okay, what fields are already trained and what fields that you don't need to train, all right? So one of the other things that I want to quickly mention is the document understanding ML package over here. So say you have a document type that does not fit into any of this document types. Say it could be a unstructured or semi-structured document that needs a machine learning model. In that case, typically I would select the document understanding model because this allows me to have a semi-structured, structured with regular fields where we see in a variance where you can define and train them with this document understanding ML package. So this is very exciting. If you already have UiPath Studio or a Community Edition or Enterprise license, do try the document understanding model because it's very versatile for your documents that are not defined by a document type. And here are some of the other samples that you have on the ML package. Great. So from this, I think the key identifiers would be pretty self-explanatory. We discovered that UiPath has a functionality where you can bring your own model, which Russell will elaborate further. And you can have models from UiPath, third-party vendors. You have multiple deployment options. You can deploy it into different environments. You can reiterate your model, and that's with the continuous improvement. Human validation. So the model has the capacity to get action-centered human inputs into the machine learning model. So if you integrate Action Center and you have an Action Center in your automation where a business user goes in and validates data that passes into Action Center, you also have the capacity to feed in those data into your machine learning model. And then you have deep integration with other UiPath products. Now we see a lot of UiPath products getting integrated with cross-platforms, SAP, OpenAI. So you can definitely integrate this with an extended third-party platform as well. So let's quickly look at some real-world AI-centered use cases, right? I'm gonna take a couple of this. So I'm gonna look at a leading Asian bank, right? So we have the customer email classification and 80% reduction in human work and 95% accuracy. So UiPath has the email classification machine learning model, which you can deploy to that. If you look into the largest mutual banks in Australia, again, loan application, you can train your model with the desired loan application and it would accurately identify the fields and values defined in that. So essentially, machine learning packages can be used into any industry that has a requirement to extract structured, unstructured, semi-structured documents. So, and this is a good way for you to find out and train and deploy. And it's very feasible and easy since the package is already deployed into UiPath. Great. Next up, I'm going to hand over the floor to Russell to talk about a use case and the walkthrough on how to bring your own model to AI Center. Russell, I'm going to stop sharing. Would you want to share your screen?
Sure. Thanks, Sharon, for that very awesome overview, setting the stage for this next topic, which is the actual demo, right? Just quickly share my screen. This one. I hope you can see my screen right now.
Yes, we can see it, Russell. Thank you.
Great. Yeah, so you've learned that you can leverage existing models, pre-trained ones that you can retrain, and all of those, which is all in good, and it encompasses really huge amount of use cases across functions and industries, right? But what if you have something outside of those models that's available, and you have the know-how or knowledge to work with Python and build your own model, right? Because I'm a firm believer of the quote that give a man a fish and he will live for a day, but teach a man how to fish, you'll feed him for a lifetime. That's what we'll do right now. But with the skills, you can literally deploy any type of models hosted in AI Center and be able to leverage it in your own automation to power up your robots, right? So I'll be going over through use case, the overview of the use case that I'm going to show and quickly show the demo and then walk you through how it works, all the nitty-gritty details, focusing on the different things or setup that you need to do to bring that model into AI Center and be able to manage and train and host as an skill, right? And for now, let's veer away from. I know you're also very popular right now. Foundational models, large language models. These are very as I said, foundational models. But now let's focus on a pragmatic model that I'm going to showcase, which is object detection, right? Very pragmatic and specific model, but still um, um, scopes a vast amount of use cases for automation, especially like for edge applications that are in devices that you can have. And if you marry it with automation, it will be much more powerful, right? So let's deep dive on this particular use case that I'll be covering, right? And then I'll be walking you through step by step what the code of this model looks like and how it's built in Python. So any type of deep learning or machine learning framework, whether it's TensorFlow, whether it's scikit-learn or whatever modules that you have, as long as it can be compiled in Python, you can deploy in AI Center, right? So for this particular use case, we'll be talking about custom object detection and tracking using YOLO V8. For those uninitiated, YOLO V8 is one of the state-of-the-art object detection models, specifically this latest version that they have. This is an acronym for you only look once. So one of the most resource efficient model for object detection, and in fact, it is also the object detection model that the pre-trained UiPath, one of the pre-trained of the open source that you in the UiPath AI Center. But what's the difference between this latest one versus the one in UiPath? That would be this is the latest. This is the state-of-the-art version, which is YOLO V8, much more lightweight and much easier to interact with, right? And I will show almost those additional benefits later, but basically it's more resource efficient. So the model that's deployed in the open source UiPath AI Center that's available can only work with images, right? Detecting bounding boxes from images and all that, right? But this one, it can work with videos as well, like clips of videos, which I will show you in a bit, right? And for the use case that we're talking about, I'll be going over through that real quick in shortly. I will go over to how this use case do ingestion, whether it's an image or live feeds coming from CCTV in 1-minute clips, and all of those process intake, which basically be fed into the model, and then you will get the output, right? Model. Once the model has inference the input. So, so this is the use case that I'll be showcasing for this demo, right? So first, the intake. So it can be, for example, a use case that I have worked on in the past for an airport management customer, right? They're managing one of the largest airport in Asia, right? Where you have CCTV feeds from the baggage claim area and has to pass through this cameras and all of those. So they want to see how they can leverage or make these cameras more intelligent, being able to detect baggage conditions, right? Whether they are damaged or whether they are not damaged for insurance purposes, right? For those that are claiming insurance for their damaged luggages, so they need this type of automation, of course, paired with the object detection, which can actually detect based on the pre-label data that you have. It can be able to detect if it's damaged or what time, for example, during this time it was damaged, something like that, right? And it can also apply for small business where you have live feeds or video clips from your stock room that, let's say, monitors every 10 minutes. Oh, this particular inventory we need to order so that we can cater the demand for next week or for the coming days, right? Another one is, of course, one of the most common application of object detection, or even so object can also be human, right? Person, right? The if you train a model with a person and even the what they wear, for example, you could be able to um, apply those bounding boxes and be able to feed that into automation and be able to trigger some sort of, let's say, oh, this particular area is too crowded. The model can also count the number of people present in that particular event. So we need to disperse additional. We need to disperse or probably deploy additional police force within that area, right? So these are the common applications, and again, not only images but also live feeds, right? And then, so this is the meat of it. YOLO V8, not only object detection, it also exposes tasks such as object segmentation. So those a task that looks at an image and also classifies, but it not only classifies, but that the object in the images, but also segments it and separates it from the other objects, right? With the shape of the object, right? Not only a square bounding box, but also the actual shape of the object, right? And image recognition. So these are the three types of task. Actually, it's detection, tracking, and segmentation. So three type of tasks that are available in YOLO V8 that you will leverage. And as an output, it will be able to automatically inference. If you're doing object detection, it will just detect the object and then output the coordinates of the bounding box, so it can based on the pre-trained label data for that model, and then it will be in a JSON format. So of course that's why we have the UiPath 4. It will accept those format and be able to deserialize the output, and then from that output, it will be able to convert back into a video or an image that can be uploaded into a repository. In this case, it's an Google Drive. And then from Google Drive, it will be able to create a data service record, right? And the front end of the output will be something like a gallery using UiPath apps, like so. As you can see here, all of this are fed into a data service entity. And one of the fields in the data service entity is the path to the Google Drive video preview, right? And so basically a gallery of those detected videos and detected images or objects. So that said, let me show you a quick demo on this. let's quickly play you this demo, and then after this, I will walk you through this. So this is a demo, a video of a recorded video of the demo I created. So this is the output, right? It's like I just simulated, let's say, a YouTube gallery, which had all the videos of the inference videos, right? And from here you can browse through the the those different output coming from the model, whether it's from your airport use case, whether it's from your public sector use case, or your stock management use case. So just to show you what the output looks like coming from the model, right? And of course, you can pair it with uh, a notification or something as part of your automation. Let's say low stock. These are the only remaining stock for the inventory, so you can pair it with your automation, right? So the key there is that the intelligence coming from the model that enables you to um, get or inference the incoming data, whether it's a video or an audio. And this is what I have showed you just now, right? But how does this work, right? Um, so this can be deployed, let's say, as attended or or unattended mode, sorry. So it can feed from a queue, right, where the queue contains the video clips or the images that you have, and then it will so this is the, let me just show you so this is the overall workflow involved in this particular process that is also depicted on the slide that I showed you, right? So typical um, transactional process, fetching from a queue, which triggers one job per new queue item. So basically, you can add a human in the loop part so that it won't interfere with other transactions as well. And then this is the meat of it, running object detection, infer and detect object from the transaction input and count detected objects, right? If you notice in the output, it has I have included some text in the bottom. So the text contains the different entities that was detected, and of course what this model type is, right? Or what it was trained with, right? So running that model, and then this is for the title, to generate the title. Of course, you can use generative AI to help you with those text generation and uploading to Google Drive, and then updating data servers, right? So so let me open this main file that we have. What does it looks like, right? Right. So this is the model that I deployed, and I show you how I deployed it in a bit. But this is how we use it in a workflow. So I have two model examples here, both of which I brought into AI Center. One is a simple object detection, which uses the pre-trained model weights coming from YOLO V8. Again, not YOLO V5, but YOLO V8, the latest one. This is a pre-trained model based off the COCO dataset, which is a common object store used to train any object detection model, the standard one. But I also retrained that's same starting from that model weight, I retrained it in order to create another version of this model that classifies or predicts or if a luggage or baggage is damaged or not. So the main difference between these two, the first one has around 50 classes. When I say classes, it means different types of objects it can detect, whether it's cars, buses, suitcases, person. While this one, it can detect two classes, right? One is damaged luggage, and another one is uh, uh, non or good condition luggage, right? So let's try this, what the output of this looks like. I'm going to show you an example. I have a couple of inputs here. Let's say, so this one, this luggage. So you can see obviously it's damaged, right? So let's just use this one. Then let's debug. Let's compare the output of this simple object detection and the object that the retrained one, right? So this is the output. So you can focus on two keys here. One is the class frequency and one is the predicted file byte array. And again, all this output are custom coming from the Python code that I deployed and hosted in AI Center. Class frequency JSON would be the class it identified and how many it has identified. Predicted file byte array is the output generated from the model. Let's say if it's an image, it will be the image that contains the bounding box, right? So in order to convert this into an actual image that you can open, right? You have to first deserialize this JSON response to convert it in a JSON object. And from this, you can get the byte array, right? The image, like so. So it converts into J array. From the byte array, you will convert into uh, uh, from the J array, you can convert into a byte array, and from byte array you can convert into a base 64, and then base 64, you can again convert into byte array, which is the actual content of an image. If you open image in a text file, it's actually a converted byte array, and then write it into the output file, which is this inferred image, right? And then you will get this inferred image like so. It's just created now, and then I'll just rename it and open it. Just for demo purposes, I'm opening it like so. So this is the original image and this is the inferred image. So this basic principle is the same thing that it does in a moving image. This is basically a video, right? It's a frame by frame images, right? It captures every frame of a video and then annotate it. So that's the basic concept that it does for object detection, right? you feed each frame into the model, and then it generates an output. For example output of a video, you see here, I just ran earlier. For videos, this might take a while. I just ran it earlier, like so. So this is the original model, right? For the retrained model, um, and this is the inference, right? For the retrained model, let's see how it looks like. Again, it outputs the class frequency and then the byte array of the file. Then let me just run that. So now this is the output of the retrained model, right? So the only difference is they're using they 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 have the same code, but they're using a different weight, which is basically the 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 different parameters or the different value of the parameters after training the model with a labeled data, such as what I did for these luggages. I labeled this is a damaged luggage, this is a good condition luggage. So that in itself is an effort, a beast of an effort as part of doing a machine learning project, right? Data gathering, data labeling, those are I'd say not the fun stuff, but once you have it labeled and trained, then you can get a model like this. Okay. So any questions before I move on to the code? Do you have any questions, or is there still anyone? Okay, no questions. So probably let's move on to the code and see how this all works. What are the prerequisites in order for you to use or host it in AI Center, right? And again, it can be any model that you build with Python, as long as you follow certain rules or follow certain structure of the classes and methods, as long as you follow a certain folder structure. So that's why if you notice in the presentation, I have in here. So these are the main things, an acronym FORT: file, folder structure, organizing the methods, requirements file, which are the dependencies of your code. And of course, if you want to add training capability, there's also a ability to add training capability. So let's go over to the Python code real quick. So at a bare minimum, you should have main.py Python file, right? And again, it doesn't have to be YOLO model. It can be any type of machine learning, inferencing, for text classification, for any types of other programmatic models. But it has to be main.py, and at least you should have requirements and requirements of text. So this is the bare minimum that you need to have, and it needs to be in any folder name. And when you zip this file, which I will mention later anyways, when you zip this file, the file name of the zip file should be the same name as the root folder that you zipped, right? But let's cover that in a bit. So that's the file or folder structure. As long as you have main.py and requirements.txt, you're on to the first step. You tick the first step, right? Now for the what's the second one? Organizing methods, classes. So from the main.py, as long as you have main class and constructors and predict, you're good. These are the methods that, and of course, not good as in you can have something out of it, but it's in terms of the structure validation or folder or content validation, it will pass when you upload to a center. But if you don't have any code in it, then it will not do anything, right? So you can have supplementary Python files, like and subfolders like this one. But the most important one is a main py and requirements that text. Right? So so for this particular code, again, we're using a specific model called You Only Look Once, YOLO, and the latest version of it, V8, right? So I'll digress a bit on how you can interact with YOLO before I move on to the contents of this. So YOLO, again, I mentioned earlier that it is the easiest to use in all the YOLO version. It's the most extensible. It can support other previous YOLO versions as well. But the main value point here is it's the easiest to use, and you don't really have to download the weights for when doing inferencing with YOLO, because the way you interact with YOLO is it's already built an SDK around it, right? If you're familiar with the previous YOLO version, you still have to do some form of prerequisite, download the training weight, download. You basically need to create a function in itself to do the prediction, to do the training, to do the validation, right? But with YOLO V8, it's as easy as doing something like this, and you can do the different modes. When I say mode, you just instantiate the model, right? And then from that model, you do prediction, you do training, you do validation. That's how easy it is, right? And you just provide a bare minimum for training, the data YAML file with the label set and validation similar. But the most important thing is the prediction. For prediction, you provide the source. Source 0 means your video cam. If it's a local path, then you can provide the path to the file, right? So these are the different modes to interact with the YOLO model. And the different types of tasks that it can do is based on this string that we specify, which is the model weight, right? Pre-trained model weight always starts with YOLO V8, and then the next string would be the how large that that model is based on the training data set, meaning how much more accurate. But of course, a larger model would be less efficient, or maybe slower, right? So you can have YOLO V8 Nano, YOLO V8X, YOLO V8L or XL or something, right? So this is the the size of the model, while dash CLS and dash SEG refers to the task. Dash CLS means classification task. Dash SEG refers to segmentation task. And without this will be the object detection task. So this is the default model, right? If you don't have the model yet, you just specify. If you don't have the pre-trained weights yet, the pre-trained, that's why it's called PT. In your local, it will download the pre-trained model locally. So you don't have to. That's why it's easier to use, right? So now that you're aware of how to interact with YOLO to predict, to train, and validate, you can build a code out of it to predict both videos and images, right? So what I did here on the predict, this is the main method. I created few things. One is it will check if it's video or otherwise it's an image. If it's a video, it will do the video prediction, right? Open the video, right? And write into an input file, since this will be hosted in the server, in the AI center server. It will have to be written on a file on that server, and then it will call the YOLO model using the predict function that I mentioned. Right. These other parameters are just the folder to specify which folder the output will be fed into, right? But the essence of that is this predict model. And if it's an image, similarly, this is only the different thing. It will just open the image and then do the prediction, right? The next thing is it will count classes, which is also a method I created here to count the classes that was identified or detected. And the result contains these bounding boxes, right? And each bounding boxes has classes. So I just count each of those and then put it in an array, right? And after that, it will so this is for the class frequency or class count. After that, it will convert it will get the byte array, right? To get the output byte array, it will just get the image. So it saved. So the predict method save the output on the server, right? Let's save it somewhere on this project folder, whether it's an image or whether it's a video. It just this method just converts it in a byte array so that it can be passed outside. It can be passed outside the predict, and then it can be part of the output from the model or from the ML skill, like so, like what you've seen here. So this is the output. Okay. Yeah, so that's pretty straightforward. The main thing is the predict, and then you count the predicted classes, and then you get the array file byte array of the output, and then you output that as part of the using you convert this into JSON, right? JSON string, which will be supported in the ML skill, right? So this is important because I think you can only output the JSON string for the custom model, but I might be wrong. It can be it's in the documentation, but this should be the format of the output coming from your custom model. Right. Okay, so once you have the code, the easiest part now is to package it, right? But before you can package it, what does the requirements that text contains? Basically, it contains all the dependencies of your Python code, In this case, I only have two. One is Ultralytics, which contains the YOLO, and another one is Pillow, which serializes the outputs. So after, so how I generate this is just running a command line. Let's say I go here. I open a command prompt and just remove this. So you don't have to manually generate it because there's a tool called Piprex in Python. You just specify the address of where what folder you want to generate the requirements from. But you need to install it first. Sorry. I'm using Anaconda for my Python packages. Okay, so if you don't have Piprex, I think I don't have it in my base environment. You need to install it first. So this will be helpful if you have so many dependencies on your Python code. So you just do a piprex and then specify the piprex. So, for that, and I'll see if I have it in the other environment. There you go. So I don't have it in the base. So yeah, so it generated the requirements, the text. So if you have Python code that has so many dependencies, you don't want to do this manually, right? Yeah, so once you have that, the next thing is to zip it, compress the zip file, and it has to be exact same name as the folder. So I have to rename it to this. Then you can go ahead and go to your AI center, go to your ML packages, upload a zip file, name your package, and then choose your package, and then input type is file. So I missed to explain this, but your code, you can accept either a file, a JSON, or a list of files. In this case, I'm accepting a file, and there I don't think there's a way you can determine here, specify here in traditional Python. It's just on the way you interact with that on the code, right? So this can mean a JSON string or an int file, but definitely not a list of file. But in this case, this will be a file because it is being opened like so. If it's a JSON string, it will just be it is processed differently. So I choose file and then choose think Python 38 and then 8. Okay. Then it will validate and then deploy, and then you can use once it's validated, you can create the ML skill here. Choose your package, object detection demo. And then name it, and then the package version, the package, and then you can create. Right? Then you can, I don't have any license available, but if you have any license available, then you can deploy it, and then you can already see it from here. Once you refresh this, if you deploy it as an ML skill, and then you can see it here. You can also deploy it as a public endpoint. So instead, even if you're not connected to the tenant, you would be able to refer to that public endpoint along with the API key. Right? So last part here, I think you noticed you can also have the capability of enabling training, but you can only enable this if your package supports it. In this case, I only have predict. I only have main.py. If I want to include training, I can have a similar structure like this. You have the main and you have the train. Train would contain the train method with the class main and the constructor similarly. And in this case, I'm using YOLO V8 model. I'm calling the train. And that's it. I think we have 2 minutes left. Sorry about that. Powering to the end. But do you have any questions? Feel free to ask and I'll answer.
So we don't have any questions in the chat, Russell, but if anybody wants to open up their mics and ask anything, please do.
Hey, hi, this is Chintan here.
Hello. Hey.
So currently the Action Center is not available as a part of a community edition, right? Like, so in that case, like,
AI Center, you mean?
yeah.
Yeah, I mean,
In like, so is there any way or like, is it something coming in future that they will be enabling it?
I think you can do
somebody
a
wants to-
trial. You can, if you go to, where's it? I think you can request for a trial.
The enterprise trial?
Yeah.
Okay.
If you're in
From the learning perspective, I was thinking like, so.
Yeah, you have 60 days for trial and you can use it
Okay.
for learning. Yeah, good question.
Thank you.
Thank you. So, yeah, Sharon, do you want to close?
Yeah, absolutely, Russell. Thank you so much for giving such a concise explanation on how to bring your own model. I really loved it. I think even in our industry, making customized ML models is still a niche topic. So I'm really glad that you gave an explanation to our community. I'm closing the event. Are there any final questions that any one of you would like to ask Russell or myself or Diana? Great. If there's nothing, then thank you everybody for joining the call. And until next time, you guys have a good rest of your day. Thank you. Bye.
Thanks, everybody. Thanks, Russell and Sharon. Great session.
Thank you.